Hello and welcome to T3 Day 15 of Honors Precalculus. Today we're going to talk about conditional probability. So let's go back to our 50 card deck fun. So when using a standard 52 card deck, how many different 7-card hands include the Ace of Spades and the Queen of Diamonds? So the Ace of Spades is one card. That's one card. And this is another card. This is a single card. So it's two single cards right there. So a 7-card hand, it doesn't matter what order it's in, it's still the same 7-card hand. So the order doesn't matter. 1, 2, 3, 4, 5, 6, 7. So the first one, we'll call it the Ace of Spades right there. And then we have the Queen of Diamonds. It doesn't matter what order it goes in. So if we've pulled these two cards out, how many cards are left? Well, there are 50 cards left if we started with a deck of 52. So for the rest of these right here, you have 52, sorry, not 52, you have 50 to choose from because you took 2 out, and you're choosing 5 of them. So what that means is this is set, you have the Ace of Spades and the Queen of Diamonds. What's left is this can change right here. This is the only thing that can change because it's 1 times 1. So in this case, you do this out, you end up with 2,118,760. Definitely use your calculator for that. So a game has 2 spinners, so 2 things are spinning. For the first spinner, the probability of landing on blue is 4 out of 5. Independently, so not related to the first, the second spinner, the probability of landing in blue is 1 out of 7. What is the probability that the first spinner lands on blue and the second spinner does not land on blue? Does not. So the probability of the first spinner landing on blue is 4 out of 5. But the probability of the second spinner not landing on blue is 6 out of 7 because the probability of it landing on blue is 1 out of 7. So not blue is 1 minus that. So it's 6 out of 7. So in this case, this is going to be 24 over 35, which is about 68.57%. So in a group of 10 people, 60% have brown eyes. So we can pause right there. If it's 10 people and 60% have brown eyes, that's 6 people. 2 people are to be selected at random from the group. What is the probability that neither person selected will have brown eyes? So how many different ways can you choose 2 people from a group of 10? Well, that's just going to be 10C2, choosing 2 people from a group of 10. Well, it says 2 people are to be selected at random from the group. What is the probability that neither person will have brown eyes? Well, if 6 people have brown eyes, that means that 4 people do not. So how many ways can you choose 2 people from 4? Well, that's 4 choose 2 right there. So this is choosing 2 people from the 4 that do not have brown eyes. That's how many ways you can do the choosing. So in this case, end up with 6 over 45, which is going to be 13.33%. So this is the number of ways you can choose 2 people from 10, but then if 60% of 10 are brown-eyed, so that means 6 are brown-eyed, that means that 4 are not. 4 are not brown-eyed. So how many different ways can you choose 2 people from 4? Well, that's this right here. So this is the number of winners over the number of possible ways to play the game, quote-unquote, the game. So let's go back to cards here. If you draw 2 cards at random from a standard deck, what is the probability that the first one is a 3 and the second is a queen? So again, how many 3s are there? How many 3s are there in a deck? Well, there's 4 of them. So the chance of drawing a 3 first is 4 out of 52. But then you're multiplying it by how many queens there are. There's no overlap between 3s and queens. So there's 4 queens, but there's 51 cards left in the deck. So it's that. So end up with 16 over 52 times 51, which is going to be around 0.603%, which is pretty small. So for number 5, it says a fair 6-sided dice. What that means by fair is that each side has an equal chance of being rolled. If we know that the result is even after a 6-sided dice is rolled, then what is the probability that we rolled a 6? Well, there are 6 outcomes in a 6-sided dice, and I just skipped a bunch of numbers there. 1, 2, 3, 4, 5, 6. Which ones are even? We have even and even and even. So if we know it's even, that means there's 3 ways, 3 things we could have rolled. But what's the chance of rolling a 6? Well, there's only 1 way to roll a 6. So the probability of rolling a 6, if we know we rolled an even, is 1 out of 3. Again, it's the number of ways to get the thing we want over the number of ways to have played the game. There are 3 even outcomes, 1, 2, 3, but there's only 1 number 6. And number 5 is an example of a conditional probability. The condition oftentimes changes the number of successful and possible outcomes, so you have to keep track of things. So in this one, two fair 6-sided dice are rolled. If at least one of the dice shows a 3, then what is the probability that the sum of the 2 dice is 7? So the best way to do this is to count things up. So we're going to write out all the ways you could roll 2 dice. So this top row is going to be what you rolled on the first dice, and this one right here is going to be what you rolled on the second dice. So let's fill in what the sum would be. So the sum, if you rolled a 1 and a 1 and a 1, would be 2, and that's why I filled in that column. So I'm going to fill in the rest now. So I filled this in. So what we need to count is how many ways can you win over the number of ways total. So it says if at least one of the dice is a 3. So this would be 1 dice is a 3, and this would be 1 dice is a 3 right there. So what you have to figure out is how many ways can you win this. And to win this, you'd have to have a sum of 7 in here. So where do you see 7s? I see a 7 right here and a 7 right here. So there's only 2 ways to win this. There's only 2 ways, but then you have to count the ways to play the game. So how many different ways how many outcomes could you have? Well, you could have all of these things. So you have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, but you double count the 6 here. You would double count that one in the middle. So there's 6 plus 6 ways to play, but you would double count the middle. So there's really only 6 plus 6 minus 1. You have to be careful of that double count. So that's 2 over 11. So this is pretty tricky again. This first column right here represents if the first dice is a 3, and this column right here represents that the second dice is a 3. Where is the sum of 7? Well, it's only in 2 places, here and here. So that's why this is 2. But then how many ways can you roll two dice such that at least one of them is a 3? Well, there's 6 of each, but one of them is with 3 and 3, and that counts twice right here in the middle where you see the 6. So you have to subtract the 1. That's the really tricky part of this. So you get 2 out of 11. That's the probability of this occurring. So now let's go to the tried and true flipping coins. 3 coins are flipped. If at least one of them comes up heads, then what is the probability that they all come up heads? So what you can do here is another case. This is another case of listing out all the ways to play this. So let's just list them out. Well, here are all of the ways, if you flip 3 coins, if at least one of them comes up heads, and you have to list them out carefully. And there's lots of different ways to keep track, but you have to make sure you write them out, all of them. So in this case, there's 7 possible ways, but how many of them are the winner? The winner in this case to get what you want is the heads, heads, heads right there. So there's 7 possible ways. There's 1 outcome that gets you the, quote, winning, the one you're looking for. So it's 1 out of 7 is the probability. Again, you have to come up with different ways to keep track of everything, but remember, at least one of them is heads. So you start here, there's 1 heads here, there's 1 heads here, there's 1 heads here, now there's 2, now there's 2, and now there's 2, and now there's 3. So you can keep track of the different ways to do this. You move the H around. So there's one more way we're going to look at for keeping track of probabilities like this that are conditional. And that's with a flow chart. So you have 2 cookie jars right here. So there's jar A and there's jar B. And jar A contains 2 chocolate chip cookies and 2 peanut butter cookies. And jar B, so let me call up jar A and B here, contains 1 chocolate chip cookie. If you select a cookie at random from one of the jars, what is the probability that that you pick a chocolate chip? So what you're going to do is you're reaching and you don't know which jar it is, and it's a fair choice, meaning you have a 50% chance of going to jar A or a 50% chance of going to jar B. And in jar A, there's 4 outcomes. There's 4 cookies in there. So there's the chocolate chip, there's the other chocolate chip, there's the peanut butter, and there's the peanut butter. This specific choice, since there's 4 options and they're all equally weighted, is I'll get this here, 0.25 right here, 0.25, and so is this. This is 0.25, and this is 0.25, and this is 0.25. There's only 1 cookie here. That's the chocolate chip, so the chance of choosing it is 1 from there, so that's the chocolate chip. So it's asking, if you select a cookie at random, what is the probability that it is a chocolate chip? So what you can do here is figure out the probability of each of these. So what's the probability of ending up here? The probability of ending up there is 0.5 times 0.25. And that's the case for each of these. This is 0.5 times 0.25. This one is 0.5 times 0.25, and this one is 0.5 times 0.25. Each of these is a conditional probability, and the chance of ending up here is just 0.5 times 1. Well, which ones are the ones that contain the outcome of winning, quote, winning, the numerator here? Well, that's we're looking for chocolate chip, or chocolate chip. So what you do here is it's really just going to be 0.5 times 0.25. There's two of them right here. So you add them together here. So 0.5 times 0.25. And then you add the 0.5 times 1 right here. This is the other outcome you have. When you do this out, you end up with, it comes out to be 0.75, which is a 75% chance. It's pretty cool. So you can make these diagrams and add up the end of the trees.